Hello everyone, welcome to my talk, Using Julia for Observational Health Research. My name is Zelko, and I'm so glad you can be here. My background and training is in biomedical engineering from Georgia Institute of Technology. Some random fun facts about myself is that I'm an educational Twitch streamer going by the name of the Cedar Prince. On Twitch, I teach about software engineering and open source development. Moreover, I'm a contributor to the Julia open source ecosystem, as seen on the right, an example of the Julia Animators ecosystem, which I co-created with my friend Ola Kroger. Furthermore, I'm a health data analytics and informatics researcher at Georgia Tech Research Institute and the Centers for Disease Control. So what is today's talk about? So I am professionally and personally very interested in the space called observational health research. So we're going to get into what that is, a case study on observational health research using Julia, and conclusions and results on what I think can be the next steps for observational health in the Julia ecosystem. So the first question is, what is observational health research? Now, it's a domain of health informatics based around what is known as real-world data. Examples of this information are things such as electronic health records, patient medical claims, basically any information that's generated when you interact with a hospital or a care provider location, and providers record information on your behalf. This leads to what are known as retrospective studies, which is the core of what makes an observational health research study. A big player in this space is Odyssey, which stands for the Observational Data Sciences and Informatics Initiative. It's an open science community across disciplines and various stakeholder groups whose goals is to establish open and community data standards on how to work with and handle this real-world data. Their goal is also to make end-to-end solutions of translating this observational data, real-world data, to reliable evidence. Now, the case study for this talk is focused around exploring health equity in the mental health care space, specifically for the U.S. state of Georgia. Here, we characterize the crude prevalence rates amongst Georgia populations with bipolar disorder, depression, and suicidality conditions. 3 of the targets that we chose to pursue was to identify vulnerable populations and their characteristics, enable large-scale observational health research, and examine disparities across populations. Now, as I mentioned earlier, real-world data can also oftentimes be very messy. Seen here is actual claims data, which is synthetically generated from the Centers for Medicare and Medicaid Services, and as you can see, can be very, very difficult and cumbersome to work with. Thankfully, Odyssey created what is known as the OMOP Common Data Model, which, as you can see here, is a database schema that specs out various tables that standardize the sort of information that can be gathered from real-world data, such as claims, such as creating tables like person, care site, concept, so on and so forth, all from this real-world data. Now, thankfully, Odyssey has many tools in its Hades ecosystem to interact with observational health data. The only problem is it's written into our programming language, but thankfully, that is not a problem for us over in Julia. Seen on the right, we can use packages such as JuliaCon to be able to call packages in the R world such as Caper and Eunomia, and then launch the Julia console from R. On the left, you can see that Julia is activating and creating the Odyssey temporary environment for this talk. And then we bring in the data frames from SQL and R call packages. And then we import the R libraries, database connector, and Eunomia. Using the native R functions, get Eunomia connection details, and DB list fields directly within Julia, we're able to interact with Eunomia, which is an OMOP Common Data Model based database in R. Here, we're generating a SQL representation of the person table, generating SQL to find the age of every single person in the Eunomia database, and printing out the SQL here. And finally, getting the counts per age across the Eunomia database. This is extremely useful for prototyping, as well as thinking about how to answer some of the questions we had in this case study. And the question is, getting back to pure Julia, how do we structure this study? Well, the core driving factors here were 3 packages known as Dr. Watson, packages.jl, and dataframes.jl. Now, as package.jl and data frames.jl are pretty well known, I wanted to take a moment to highlight Dr. Watson. It's somewhat of a meta package that allows one to quickly and easily create a project directory structure for a given study. Seen here is the structure of the study that we followed, which had folders for research, data, plots, and so on and so forth. Not only was this useful just for an organizing principle, but it also made communicating with my students a lot easier as we collaborated and brought this project to life, more and more investigated different questions that arose through the course of the study. Now, due to the composability of the Julia ecosystem, I was able to create two novel packages known as the OMOP Common Data Model Cohort Creator and the OMOP Common Data Model Database Connector. Admittedly, those are rather long names, so they'll probably be renamed in the future. Seen here is just an example of me interacting with another synthetic database, finding all those individuals who have conditions related to bipolar disorder. Seen here is me also generating Julia representations of the OMOP Common Data Model. Now we find the persons in the database who have conditions related to bipolar disorder, and we find every single one of their age groups, and then finally we can generate the group counts for these bipolar persons for privacy preserving purposes. Now, moving on from here, the question is, were we actually able to derive meaningful results and conclusions from this initial case study? And the answer is a resounding yes. Seen here are results from actual data from the Centers for Medicare and Medicaid Services for the state of Georgia, where we calculated the crude prevalence of depression and bipolar disorder. Suicidality not shown. Across races, genders, and age groups, we were able to identify very quickly apparent disparities, as well as very jarring representations of what disparities can look like across the various subpopulation groups, therefore motivating future research in the future. Moreover, I was able to present this work at a live conference and was able to use this Data Explorer dashboard that I created using the wonderful ecosystem of the Genie framework to demonstrate and show across races, genders, and age groups various conditions and prevalence rates for various demographics that someone might be interested in. It was an extremely powerful experience as I was able to show and point to the screen to say, here you are represented in this data to people who might not typically be represented in studies such as these. Now, as for the future of the observational health research ecosystem in Julia, what does that look like for me and for others? Well, I imagine publishing on this work, as this work was immensely successful, and also going forth with building more studies related to this work. Moreover, I imagine tighter integration with the Odyssey ecosystem and JuliaHealth organization here in the Julia ecosystem, as well as developing and building upon the work that I've been doing in JuliaHealth organization for specific tooling for big health data applications. For any questions, feel free to get in touch. And a huge thank you to my wonderful students and colleagues, and special shout outs to Clark C. Evans, Kirill Simonov, Kristen Koska, and James Fairbanks for their help and support with this project. Thank you so much, and have a wonderful day. Bye.